Hello? Can you hear me? Awesome. So my name is Sakuyo Suzuki. I work for developer relations team at Google. So today I'm going to talk about material design. Okay, before jumping into presentation, how many people knows material design or heard about material design? Not many, all right. How many people implement or actually developed app using material design? Very small. Okay, so today I'm going to talk about like high-level principle of material design with actual sample apps. So material design is design system Google announced at Google I/O in 2014. So lots of people ask like why Google is building design system or design framework, right? Google's search company, but now we're providing design system. One of the big contexts is we now see there's lots of devices. You probably have tablets, smartphones, sometimes wearables, automobiles, TV. This is just example of like devices runs Android OS. And we realize there's so many users touching your application with different devices, right? So we think it's important to have design system to give consistent user experience, even though they're using different devices. So this is the main reason we created material design. So depends on users can access to your apps from wearables or smartphone or tablet. It's nice to have same user experience so users do not have to confuse depending on the devices. So I'll start with what's core principle of material design. And there's 3 core principles of material design. First is material surface. So I'll talk this later again, but material design, we're taking all the metaphor from real world to digital devices. And first metaphor is we're using paper, like normal paper like this, but we call digital paper. And all the surface have different elevation, heights. And second principle is print-like design. So design, there's great history from like print design, like web design. So we're taking inspired from those print design and trying to put them to optimize for digital devices. Third is meaningful motion. Meaningful motion is, so in real world, things doesn't change from place A to place B, right? There's always like a time between if you move something, it doesn't like change or it doesn't disappear or pop up. So those motion actually helps a lot for users to understand what's happening on your applications or your website. So today, I'll talk how this principle works in real apps by using example of this application here. So if you're interested, you can go to g.co code labs MD style. It's actually a material design code labs, but you also can download the sample app right here. This is a sample app you can download. Okay, let's move to a first principle, material surfaces. So as I said before, material design, we're using real world we're using digital paper as a metaphor to structure the application. So unlike real paper, this digital paper can move or can like lift or can split or recombine. So this is a good thing about digital paper. Like real paper, you can't recombine after split, right? So each of these digital paper or surface have different elevation. And it actually makes user easier to understand about your app structure. For example, this is a dialog, right? Permission dialog. This should be a most important surface. So it has highest elevation. So user can easily understand, oh, I see this surface higher than any other surface behind. This should be most important ones, right? So this actually gives the user easier to understand what's going on with your apps. And the other example is when you scroll, how this green toolbar spins at the top and lifts, and white paper goes underneath, right? So this actually gives users understand, oh, this green toolbar, which is a menu of this content, title of this content, is more important than the surface itself. So this actually gives users better understanding of structures as well. And if you go to material design website, you can access from design.google.com. You can see all the different elevation per component. This is our suggestion. So for example, dialog has higher elevation. Oh, this is how you look from the side. So like this is a normal surface, and here's like floating action buttons, and this is navigation drawer, and here's dialog. So we kind of gave a guideline to easier for you to create the right elevation. But if you want to watch a dialogue and set elevation, it's a painful process, I think. So we built a support library called Android Design Support Library in 2015, and it's now open source, so you can just use whenever you want. And using this design support library is very easy. Current version, latest version is 24.0, which came out a few weeks ago. All you have to do is add this one dependency to your Gradle file in your Android apps. And if you're using this Android Design Support Library, current latest version actually has 4 components: floating action buttons, tabs, navigation drawers, bottom sheets. And we actually created new layout called coordinated layout to coordinate each of these components. So fab, floating action button. So if you see some of like Google's apps or any Android apps using material design, you see this circle button on the bottom right. This is very iconic surface in material design. So we call this floating action button. And we use this for most important action, primary action for your applications. For example, like Gmail, floating action button, it's not press. It's usually a pencil, icon with a pencil, because the most important action should be write emails, right? Or if it's like a music application like Google Play, it has like a triangle button, which says play music. So floating action button is one of the most symbolic component in material design, but we didn't. All the developers have to create like a circle view before we develop this design support library. So by using design support library, all you need is you can create with this few lines of XML code, and even you can change the color right here with attributes, and you can change the size of floating action button with this attributes fab size. So because all the application has different color, different brandings, so we want these floating action button easier for user to find it. So depend on your primary color of your application. For example, this is like light blue. We recommend like yellow as a floating action buttons color, so it's easier for users to find where the floating action button is. So it actually fits with your branding of your applications. Second is about navigation. For mobile devices, there are a variety of patterns to navigate from contents, or move from one page to other pages. First is tabs. The other is navigation drawer. If you click this hamburger button, you see another surface coming out. And third one we recently added is bottom navigation. And fourth is navigation by touching each contents, like touching cards or tiles. And in Android Design Support Library, it supports 2 types of tab layouts. One is if you have, let's say, only 3 menus, it fits in it actually design support library splits into equal space and put it into your side of the screen. But if you have more than like 3 or 4, or if you have lots of tabs menus, and we automatically makes it scrollable, so users can find or move to contents by scrolling these tabs. And of course, you can put these using, we wanted to make this easier to work with activity Java file as well. So we're just using View Pager, it syncs with your other contents. And navigation drawer, you probably might have seen some of these like surface coming from the navigation menu coming from the left. We call this navigation drawer. An important part is you can use this space here to express your login status or brandings, or sometimes like user wants to change the color. So this is an XML file for navigation view, but you can see you can customize drawer header, and in drawer header you can customize depends on your brand or depend on users like upload photos. And menus, you can also create custom menus here. And depends on what type of application you make, you might want to create like dynamic menus. For example, if user is signed in already, you want to show sign out. So for those ones, you have to work around with Java files, but you can create dynamic files here. OK, let's talk about coordinate layout for now. So coordinate layout is a layout we announced with under design support library. So coordinate means like it's actually coordinate the views. So one of the great example is if you have a snack bar and floating action buttons. If you click this floating action button and snack bar appears, then this floating action button automatically moves up. It doesn't like collapse. Because material design, these are on same elevation, same height, so it should move, and it doesn't conflict. So without writing any code, coordinate layout actually coordinate two views, snack bar and floating action button, and coordinate them. And you can actually give better user experience using coordinate layout with combining with toolbars. For example, if you want, so even though smartphone has a larger size smartphone nowadays, the screen size is very limited. So you want to show as many content as possible, right? So sometimes you just want to hide toolbars when you're scrolling something. So using coordinate layout, you can scroll or you can hide this toolbar, which you don't have to show all the time. But you might want to show tabs, because you might want users to change the contents, even though you want to hide a toolbar. Coordinate layout is some example that's, hey, coordinate layout, I want to hide toolbar, but I want to leave tabs. So this is kind of coordination you can do. Coordinate layout can coordinate your views. And this is like you can create, use this coordinate layout with very simple lines of XML scheme. And this is an example which I showed in the last animation, is just add two types of recycler view and upper layouts within coordinate layout. And coordinate layouts behave depend on how you put these attributes. OK. Bold graphic design. So second principle of material design is we inspired from great design from print and bring it to digital world. So material design is a system to make designer or developer easier to express your branding. So for example, Robinhood, this is one of the applications we gave award this year. You're using dynamic image, like using big image to express their brandings, and like a cover of print magazines. So material design is not limited for like traditional app design, but you can do you can show your branding. I mean, you can show your colors or image and system to support those color brandings. And of course, unlike print design, digital paper can move or squeeze or move around. So you can do more dynamic stuff. For example, like by using collapsing toolbar layout. So for example, you have a great picture, and you want to, when you scroll, that great picture transform into toolbar. So you can give users first view, give nice big picture, and when it scrolls, actually it turns into toolbar. So when you use material design, please do not hesitate to use big image, and please use anything you want to express your applications, I mean branding to your users. But important part is when you try to put like lots of contents, it starts getting messy, right? So we actually, in material design, we have a guides to keep the content in consistent layout. It actually gives rhythm for users to understand your contents better. So we are recommending like 16 dp from the side for margins, and we recommend the title search from 72 dp. I won't go too deep inside because there's so many stuff in here. So you can always check with our material design spec site. It actually gives you all tiny detail about recommended like line heights, margins, grids, and everything. And even for the fonts, sometimes we suggest this is recommended size fonts for headlines. This is recommended font size for text and displays. So if you're interested, please check material design site. And these are all using material design spec fonts. So if you download that app, which I mentioned earlier, and you can see how these align with the grids. And last is about meaningful motion. So I will not go deeper about meaningful motion because John, who is having session right after me, is going to present all about motion design of material design. So his session is everything about motion. So I'll just go quick overview of motion, quick update about motion. First of all, we added motion guideline in our material design spec site. So if you're interested, you can check motion guideline material design site. And this May, we didn't announce big, but we silently announced Vector Drawable Support Library. So right now, if you want to show, create this favorite buttons or share buttons, you have to create, I think it's same with web, right? Web or Android. You have to create with PNG files or JPEG or bitmap. And Android, there's so many types of screen sizes. So if you're an Android developer, you might know you have to put 4 or 5 different sizes of PNG files, depends on the size of screen. And this is pretty nightmare for designers because you have to put 5 different sizes, and you actually have large APK file size. And now, this is actually using vector support library. So this is actually vector image. This is using path. It's not PNG, or it's not JPEG or bitmap. It's one vector file, and it actually, so it's vector file, so you can expand as much as you want, or you can squeeze as much as you want. You don't have to worry about resolutions anymore. And so the only thing you have to do is put this vector drawable in your application, and it works fine. And this, by using vector support library, it works all the way back to API 7. That's Froyo. And if you want to make animation vector drawable, it works from API 11. So if you're thinking about using any icons, I really strongly suggest to use vector drawables. And if you, this app is already open source, so I won't go deeper, but you can just see how this app is using vector drawables for these images here. And great thing about vector drawables is if you have, let's say, if you want to change, if you want to transform these icons, it's very hard to transform, let's say, JPEG, one JPEG to other JPEGs. Only thing you can do is like a fade in and fade out. But since vector drawable or vector is made by path, you actually can transform these paths and change. You can tell users that the status is changing. So for example, like this is uploading files, and you can see these animations, and you can tell users animation like uploading is done. And this is like very small, tiny animation, but it's actually very effective for users to understand what application status is right now. Okay. So animated vector drawable is a bit more trickier. Like these animations is a bit more trickier. So I recommend to start from vector drawable first. And if you can find good way for showing this kind of effects animations, that'll be very helpful, useful, I think. Sorry. So just before wrapping up, today I talked about 3 principles of material design. First, material surface. Second is like print-like design. And third is meaningful motion. And I always get similar questions, I think, which is very important question, or feedback, is everyone keep asking me, okay, I understand material design, but material design, or if I use material design, it looks like Google's app, because Google uses material design. So before ending my session, I would like to show some of the great example, not Google, like everyone, other developer like you, created. So okay, these are all great examples of material design apps which not Google, third-party designer or application designer made by using material design, a design system. So you can imagine that material design is not like a guideline or not like a very strict rules. It's more about we would like to help like application designer or developer to help to create better apps, or other word is we want to help you express your branding for everyone, not only for mobile developer, but mobile users, but also like tablet users or users accessing from wearable devices. So I would love to see great material design apps coming out from Korea, and I'm looking forward for that. So here's all the links to today's materials. So link on the top is the sample app I used for today's presentation. And if you go to google.com/design, you can access everything about material design spec to all the link to those icons. And here's a link, one of the sample app my colleague Nick Butcher made. It's called Played App. It's actually a great example. You can actually, it's open source app, and you can see how he is using animation and the graphics and other material design principles. Okay, thank you very much for your time. Thank you.